Hi, I'm Kian, and today I want to show you how to find if a series is converges or diverges using two methods, the root test and the test for divergence. So we had this series from 1 to infinity of 1 minus 1 over n to the nth power. So if I want to use a root test, so what we should do is that we should take the nth term, nth root of 1 minus 1 over n to the power of n. And you see that this n and this n cancels, and what we are left of is just 1 minus 1 over n. Our next step is to take the limit of the nth root of the actual series. So we should evaluate the limit as n approaches infinity of 1 minus 1 over n. And you see that if you put infinity, you get 0, 1 minus 0 is 1. But in root test, as I explained for you, when we're doing root test, the limit of the nth term of the series, if the limit is less than 1, then we can conclude that it converges, the series. If it is greater than 1, we can say it diverges. But when it's equal to 1, it's inconclusive. That means we have to do more work, and we should use another method. So root test won't work in this case. So this means inconclusive. So we get won't work. The next one we test for divergent. How? We should take the limits of 1 minus 1 over n over n. So we should take the limits as n approaches infinity of 1 minus 1 over n to the nth power. So this limit might seem a little difficult, but we can use another limit that has been previously proved to solve this limit. So there's a limit, we say the limit as n approaches infinity of 1 plus a over n to the power of b times n power is e to the power of ab. And this is very similar to this. In this case, we can see that a is equal to -1 and b is equal to 1. So our final answer would be e to the power of -1, which is equal to 1 over e. Now, the limit converges to 1 over e, but the series doesn't converge because the limit converges to a non-zero value. We should say that 1 over e is not equal to 0, so this series actually diverges. Thanks for watching. Please subscribe and let me know what to do next.